Hello everyone, this is Anubhav Bhardwaj along with my other team members Sachin Chauhan and Dhananjay Maurya. We have completed our project that is Contextual AI Assistant using Transformer and NLP under the supervision of Professor Govind Kumar Rahul sir, Assistant Professor, Department of Computer Science and Engineering. Our project ID is 23. So the problem statement is we want to develop a NLP model that can give or predict the accurate answers of the question that are being asked to the system based on the text provided to it, so that the total amount of information searching is being reduced. And the aim of our project is we are supposed to develop a model with objective to bring the human computer interaction and to enhance the information searching method to make them more time efficient and accurate. In order to achieve this, we have developed a NLP model that can recognize the question that is being asked, and in return it can answer the question according to the text provided to the system. Converting these recognition into text so that it can be easily interpreted and understood by the people. It will be a platform for the student and all other people who are facing same problem of information searching for specific information in huge paragraphs and PDFs. The difficulty that many people are facing that they waste their time reading the wrong paragraphs, articles and PDFs online in order to gain some useful information from them. It happened quite often and the information they are seeking for is not present, and sometimes it has happened that the information they are seeking for is not present in that paragraph, article or PDF. Let's imagine the content is too long to read and the consumer or the user aren't sure if the content unsure if it contains the information they need. This barrier is most of the time remain negligible but necessary to be removed. In order to achieve this, we are utilizing Transformer, which is a TensorFlow library based on advanced NLU models such as DistilBERT. This study helps people to understand the offered solution and how to put them into action to solve this problem. The suggested model aims to convert provided text into token and then returns an answer as per the question asked. This can also be done via speech to text method. This model is accurate and every time it gives the right answer whenever the question is asked. So before coming to the proposed method, we have gone through some of the already implemented technologies and research papers that are as follows. First one is KBOT, a knowledge graph based model for natural language understanding over linked data. This was proposed in the year of 2020, and the algorithms and the notations used is NLP, NLU, SVM and Flask. The advantage of this method is multiple knowledge bases are used here and open access to involve a wide range of users. It also supports analytical queries, but it has some limitations as well. Complex to build and it is less user interactive and more graphical data is required. Similarly, the other research paper that is a self-learning chatbot from user interaction and preference that was also proposed in 2020, and the algorithm and the technologies are used. Technologies used are PHP, NLP, RASA, MongoDB, HTML, CSS. It is user-friendly, interactive, and easy to use, but it does not support analytical queries. It is limited to specified number of questions and do not provide precise answer. The other research paper that is an intelligent model using deep learning with bidirectional RNN and attention model. This was also proposed in year 2020, and the notations and algorithm used are ML, NLP, deep learning, RNN. It is easy access to information, precise prediction, and it has some limitations, that is complex architecture limited to similar type of data sets. Similarly, these are some of the research papers and some of the technologies that are already there, but they have some limitations that we are trying to remove from our method.
Hello, my name is Sachin Chauhan and now I will discuss our proposed solution. So after all the findings and literature survey, we came to the result that if we use transformer, which is a library having many pre-trained modules based on latest NLP models. So in our project, we use Distilbert, also known as Distilbert model, which is an advanced version of BERT model, which is very lightweight, effective, more accurate, and at last, it is very easy to implement and work fine for large sequence strings of text. Now let's talk about how it works and what is the use of Distilbert in our project. Distilbert used for tokenizing the context and store it in the array, which is further used for question answering. We also use Distilbert, another model, which is Distilbert question answering module, to process over the question, and that we select the highly matched token based on the probability score of the token. Let's dive more deep into this. How it tokenizes the text. There are two subunits in tokenized module of Distilbert. First encoder and second decoder. The encoder further have two more layers in it, used to tokenize the context. The first layer is self-attention, which is used to process over sequence of string, and then which is further go to feed forward, which then uh, process over the tokens and store it in array. Similarly, decoder also have some subunits and layer within it itself. It has same two. It has three layers. The two layers are same as in encoder. First is feed forward and self attention. The another third one, which is different from encoder, is encoder decoder attention. So now using these two, we tokenize our text into token and store it in array.
So now let's move towards the implementation part. Firstly, we have to copy the some context and paste in the context field, and then ask any question on this inputted context.
Mughal Emperor Shah Jahan.
As we can see that our model are able to give the correct answer, and we can also ask multiple questions on our model. And not only this, our model is able to uh, take the question in the speech form, and it also gives the answer as the speech form.
Hello. Now let's come to the coding part. So app.py is our main file, which is responsible for all the connection of this project. So let's start from here. We import Flask. The library we used in our project are these: Flask, SQL, Acclaiming, TensorFlow, Transformers, String, and PyTT SX3. From in transformers, we imported two more pre-trained models: Distilbert Tokenizer and TF Distilbert for question answering. These are two separate models extracted from transformer, which we'll use for tokenizing a context we put before welcoming to the our welcoming into our project. So this is a some kind of schema designed for us signing. There are four fields: ID, username, email, and password. Now it's the main function where we tokenizing the context of which passed into an input box by the user. So this is the def interface is a main function which is responsible for tokenizing the context. So these we extract, we import models, digital word model from other files as shown here, and then we put them together and encode them. Then we in line number 24 we are encoding the context we got in the input box passed by the user, and in line 27 to 28 we are converting the tokens into, it means we are decoding the tokens all we encoded previously, and then we running a loop to calculate the answer into a sentence. uh, Now these are some are routes APIs. There are 4 APIs, and this template section has got our front end part, and these are some libraries, environment libraries we are using. So let me minimize it first for the better view. So it is an environment environment folder where we put all our essential and useful folders, like our pre-trained models of Distilbert, BERT, and many others. So this is the environment file, and now let's come to the model part, which are the main part for our project. We are using Distilbert, and we are describing our Distilbert in in the model folder. So this file is its config file. So and this is the test data for that Distilbert model, which is basically process over the questions. What does it mean? What are the user asking basically? And these are some associated files. Our conclusion is our finding in this project work in this contextual AI led to the conclusion that if we use Hugging Face Transformer rather than other technologies, gives us more accurate system with less complexity, where it is easy to implement and better results. Transformer gave us lately implemented NLP based models like Distilbert, which are very lightweight, and it Transformer also have other various other models like BERT, which shows better confidence and more appropriate outcomes in comparison with other related technologies. The further advancements that can be done is we work on the logical reasoning part, so that the model can give the answer of the logical questions also. As of now, our model is able to give answer accurately based on the text provided to it. Thank you.